Okay, so today's notes are on factoring trinomials when a is equal to positive or negative 1. It's section 4.4b, and our content objective is going to be to factor quadratic expressions in the form ax squared plus bx plus c when a is equal to plus or minus 1. And the language objective is to use correct terminology to explain that process. So we're going to start with an example. So first thing, our example, I want us to factor x squared plus 9x plus 20. And again, this is in the form ax squared plus bx plus c. So I put this here because we're going to refer to the coefficients as a, b, and c based on which term they're the coefficient of. So in this case, we're going to start by labeling our a, b, and c values. Since there's nothing written there, a would be 1 since that's the coefficient of x squared. B will be 9 since that's the coefficient of x. And c, our constant, will be 20. So these will come up repeatedly throughout our quadratics units, so make sure that a, b, and c, that makes sense, which coefficient we're talking about. All right, so our step 1 is going to be to find the factors of c that sum or add to b. So I'm finding the factors of c that add to b. So to do that, I'm going to write down my factors here. So you can be pretty thorough. One factor of 20 is 1 and 20. Then you have 2 and 10. Then you have 3. It doesn't work, so 4 times 5. And 1 and 20 don't add to 9. 2 and 10 don't add to 9. 4 and 5, however, add to 9. So I know these two are going to be my terms that I'm going to use in my binomials. And the next thing I'm going to do is pretty straightforward. I'm going to write them as two binomials. With the factors as the second term in terms in each. Factors as second term. So I'd have x as my first term plus 4, and then x plus 5. So that is my factored form of that quadratic. Just to be sure, you can always check your solution by distributing like we practiced the other day. So if I FOIL or use the FOIL method to multiply this out, I get x squared plus 5x, first outer, plus 4x plus 20, which gives me x squared plus 9x plus 20, which was what I started with, so that checks out, and my factored form is indeed correct. That's a 5 here, sorry. All right, let's do a quick check of that. So I want you again to factor this, but we have x squared plus 14x plus 40. So go ahead and pause this, try that one on your own. I'm going to go over it now. So I'm finding factors of 40. I again can be thorough, so I know 1 and 40, 2 and 20, 3 doesn't work, 4 and 10, and that will add to 14. So I know I'm going to have x plus 4 times x plus 10, and that should be correct, but just to be safe, we can check our solution. So if I FOIL, I get x squared plus 10x plus 4x plus 40, combine like terms, and I get x squared plus 14x plus 40, which checks out since that's my original equation. So that's my factored form. I'm going to go ahead and do another example when we have some negatives thrown in there. So if you have any questions about either of these examples, make sure you jot them down. I'm going to flip the page. So our next example, I want us to factor x squared plus 14x minus 72. So this one gets slightly different. So I'm still going to start by finding factors of c. That sum to b. But when you start having negative and positive signs in here, you have to sort of think about and reason through some patterns that you see. So if this adds to a negative but multiplies to a positive, that means that one of my terms will be negative and the other will be positive. In this case, the greater number is going to be positive since it's adding to a positive number. So I'm going to make a little note here. Note, since c is negative, and b is positive, we know the greater number is positive, or greater factor is positive, and the lesser is negative. So also things you can reason through, if you have a positive but they add to a negative, that must mean that they're both negative terms, because a negative times a negative gives you a positive, but would add to a negative. So when you see these negative and positive signs, make sure you do some reasoning on that front. So my A value is still 1, B is 14, and C is negative 72. So I'm finding factors of negative 72 that add to 14. I know my lesser factor is negative, so when I'm making my list, I'll make my negative ones or my lesser one's negative. So I have negative 1 and 72. I have negative 2 and 36. I have negative 3 and 24. Still none of these are summing to 14. Then I have negative 4 and 18, which if I add negative 4 plus 18 gives me 14. So that will be, or those will be my factors that I will plug into my equation. So I should get x minus 4 times x plus 18. So this should be my solution. My step 2, sorry, I skipped this. I wrote my binomials, just like we practiced in the last example, and then I can check this just to be sure. So if I use my FOIL method, I get x squared plus 18x minus 4x minus 72. I combine like terms, I get x squared plus 14x minus 72. That checks out, so I have correctly factored that problem. All right, make sure you write down any questions on that, but we're going to do a quick check together. So I have x squared minus 11x plus 30. So I want you to try to reason through that one on your own. Pause it, give it a shot. I'm going to go over it now. So I'm finding my factors of 30 that add to negative 11. So since they're multiplying to a positive but adding to a negative, I know they're both going to be negative. So if we're going to be thorough, I could have negative 1 and negative 30, but that won't work. Negative 2 and negative 15. Negative 3 and negative 10, or negative 5 and negative 6, which will be my pairing here. If you start reasoning through this and you can get to this faster, you don't have to list every factor. If you can do some of that in your head and sort of whittle it down sooner, by all means, you can skip this list if you can figure that out faster. So my factors should be x minus 5 times x minus 6. And just to be sure, we can use our FOIL method to check. So I get x squared minus 6x minus 5x plus 30, x squared minus 11x plus 30, which checks out. So this would be my factored form of that quadratic. All right, make sure you write down any questions, comments, concerns on that. We have one last example, which we'll do super quickly. So our last example, I want us to factor negative x squared plus 13x minus 12. And we're going to start this by factoring out negative 1. So step 1, we're going to factor out negative 1. So if I factor it out, I get negative x squared minus 13x plus 12. Now I'm going to factor what's inside the parentheses like I did with all the other problems. So I'm going to factor as usual as my second step. So if I have A is 1 in the parentheses, B is negative 13, and C is 12. So then if I factor this per usual, I'm finding factors of positive 12 that add to negative 13. So like our last quick check, I'm going to find two negatives that sum to negative 13. So I can start with negative 1 and negative 12, which works out perfectly. So that's the factor I'm going to use. So I have, when I factor this, the negative is still there. So you carry the negative through, and then I have x minus 1, x minus 12. So my last step is going to be to check this. So I'd have negative, if I do my normal FOIL method, x squared minus 12x minus x plus 12. If I simplify, I get x squared minus 13x plus 12. If I finally distribute my negative, I get negative x squared plus 13x minus 12, which is back to my original problem, meaning we had factored this correctly. So this is my factored form of that quadratic. Last quick check, final one, and do together. Negative x squared plus 14x plus 32. Try that one on your own. I'm going to go over it now. So again, I start by factoring out the negative. So I have negative parentheses x squared minus 14x minus 32. So I'm finding factors of negative 32 that sum to negative 14, which means I'm going to have one positive and one negative solution, and the greater one will be negative. So when I factor that out, I could do 1 and negative 32, which won't work, but I could also do 2 and negative 16, which does sum to negative 14. So those will be the two I choose. So if I write that, I have negative x plus 2 times x minus 16. And then to check it, I would distribute it out. So I have the negative x squared minus 16x plus 2x minus 32, combined like terms, and I get negative parentheses x squared minus 14x minus 32, and distribute my negative last but not least. Change all the signs, and that is indeed what we started with, which means I have correctly factored that problem. Okay, so we're all done. Make sure you write down any questions, comments, concerns you have on any of these examples or quick checks so that we can go over them together in class.